Hello James! Welcome to the second episode of FAQ series for BITSAT 2022. Now this is a series wherein we discuss the frequently asked BITSAT questions and these questions are selected based on their weightage over the last 15 years in BITSAT. Okay, so I hope this series will help you a lot in your preparation, and today we are discussing the chapter Kinematics 1D or motion in a straight line or motion in one dimension, whatever you might call it. Okay, so we'll discuss the frequently asked questions from this chapter today, and let's aim for 35 likes on this video. So 35 likes on this video and this series keeps going. So let's get to the video now. So before we dive straight to the questions, let's briefly discuss the topic weightage for Kinematics 1D over the last 15 years in BITSAT. Now, Kinematics 1D is a very important chapter as far as your BITSAT is concerned, majorly because you can expect at least 1 to 2 questions from this chapter. Every BITSAT paper that you are going to answer will include at least one sure question from this chapter. Okay, so it's an important chapter over here. Okay, so let's see which topics are important over here and what are their scores. Okay, how many questions from those topics are asked in BITSAT. Okay, coming to our first topic, average and instantaneous terms. Here you learn about average velocity, average speed, average acceleration, instantaneous velocity, instantaneous acceleration, and things like that. Okay, so from that section you have been asked 3 questions. Okay, 3 questions over the last 15 years. Okay, now these are very straightforward questions and you'll be able to do them. We'll come to the questions in a while. Now the second topic over here to focus is uniformly accelerated motion. Okay, now questions again here are straightforward. Only 2 questions were asked in the 15 years of consideration, and yeah, they are very straightforward. They just include the usage of your equations of motion, 3 equations of motion, okay, which you use in uniformly accelerated motion. Now the third topic, which is again a very important topic, questions are regularly asked from this topic. Okay, it's motion under gravity. Okay, motion under gravity is itself an example of your uniformly accelerated motion, but yeah, it's a special thing, so that's a different topic. And here 3 questions were asked over the last 15 years. Okay, and these questions are a bit conceptual, they are a bit unique, so you have to proceed in a particular way. You'll get to know when we do such type of questions. Okay, so here you cannot expect straightforward questions. In motion under gravity you have to go a bit higher than the usual level what you're studying. Okay, it's basically unique questions. They basically bombard you with a particular type of questions. Okay, you'll come to know when we discuss the questions. Okay, now the next topic is non-uniformly accelerated motion. So we have discussed about average and instantaneous term. This is uniformly accelerated motion. This is also an example of uniformly accelerated motion. Now next topic is obviously non-uniformly accelerated motion. Okay, again very straightforward questions. 3 questions were asked over the 15 years. Okay, and yeah, it just includes the usage of formula. Okay, if you know the concept, you'll easily be able to do it. Okay, now coming to the next topic, which is my favorite, relative motion. Right, from relative motion 3 questions were asked, and again these are very straightforward. Relative motion in itself is something which simplifies our study of motion. So yeah, those questions are also simple. Sometimes they might ask you for the forming the equation, okay, when 2 objects meet, right, those type of questions in relative motion. And yeah, sometimes they might ask you for the equation of time, or sometimes they might ask you to solve the equation and tell the time. Okay, we'll come to the questions. Then the last thing is about graphs. Okay, now graphs, again very straightforward question. They might give you the graph of v versus t graph and ask you for the acceleration. You can just find the slope and that will be your acceleration, right? So very straightforward questions from this topic, this topic, not this one. Again, this topic, very straightforward questions. Straightforward questions from here as well. So motion under gravity, a little bit of conceptual topics. Okay, and a conceptual topic and conceptual questions are being asked from it. Okay, finally we have other basically means that the questions that include logic over here. Okay, sometimes the questions on kinematics 1D have to be solved using logic. You cannot use the equations of motion every time. Sometimes you do need logic, right? So those type of questions are kept separately over here. So those type of questions were also asked. Okay, we'll come to that. We'll discuss every single category of this, and I will make you feel confident to solve such type of questions. Okay, and yeah, let's get to the questions now. So coming to our first topic, which is nothing but average and instantaneous terms. Okay, so as you can see, the questions in BITSAT are asked on average speed, and here we have a question on your instantaneous term. Okay, here you are supposed to find the acceleration and you are given this equation over here. Okay, so let's go through the questions. Let's try solving them. Let's see if we can solve them. So first question, car covers 2/5 of the total distance with velocity v1 and 3/5 of the distance with velocity v2. Okay, what is the average speed? Now this is a very straightforward question. You learn it in the first few classes of your kinematics 1D. You learn the formula of average speed, right? So average speed is given as total distance upon total time taken, right? So total distance upon total time taken. Okay, so nothing about time is told. Okay, but we know the distance, right? We can assume the distance to be 5. Now I'll take 5 very wisely, because you can see 5 in the denominator, right? So if I take the total distance to be 5, you can say that the 2/5 of 5, 2/5 of 5 will be 2, right? 2 by 5 into 5, 5 and 5 will get cancelled and you'll get 2. Okay, so 2 is the 2/5 of 5. Okay, that is what I'm saying. And here you'll get 3/5 of 5, which is again 3. You can take any random distance x, and that this distance will be, if you take this as x, this will be 2x by 5. This will be 3x by 5. But here, for simplicity, I have taken this x as 5. Okay, you can take it as anything. Anyways, it will get cancelled. So 5 and 5 here, it gets cancelled. Here also it gets cancelled. Okay. So you get 2 and 3. So this distance, it travels with a velocity v1, and this distance, it travels with a velocity v2. Okay, now you are supposed to tell what is the average speed. Now we know the formula for average speed. It's total distance upon total time taken. So total distance, we have taken it as 5. So 5 is our total distance. It may be in any units. Okay, as of now we don't know the units, right? So 5, and then total time taken. Now nothing about time is told, but time can be written as distance upon speed, right? And we can break it into two halves for this one and this one, right? So you can write distance upon speed. So this, for this time, you can write distance is 2. Okay, so for the first half, car covers 2/5 of the total distance with velocity v1. So 2/5 of our distance is 2, and with velocity v1, time is equal to distance upon speed. So this is the time for this journey, and time for this journey will be distance upon speed. Again, distance is 3 over here and speed is v2. Now you can clearly see the answer from here. Okay, you can solve this, you can take the LCM. So you'll get v1 into v2, that will go on top, 5v1 v2, and here you'll get 3v1 plus 2v2, right? 3v1 plus 2v2. Okay, so option D is the correct choice over here. Very straightforward question, as you can see it. Okay, if you didn't get it, let's try it again. Okay, let's try it. Let's try speed running it now. Okay, so here they have already given you the total distance as 3s. Okay, so it travels a distance s. So the total distance is 3s. It travels distance s with velocity u, travels distance s, the next s with velocity v, the next s with velocity w. Okay, so we have 3s, so 1s, 2s, 3s, right? So it travels this distance with velocity u, this distance with velocity v, this distance with velocity w. Okay, you are again supposed to find average speed. So average speed, as you know, is given as total distance upon total time taken. So you already know the total distance upon the total time taken. Time can be written as distance upon speed, and you can just add this 3 times, right? So distance upon speed, this distance upon the speed. So in this journey we have distance as s, and speed in that journey is u. So time for this journey plus time for this journey, distance s, and again we have the speed as, now the speed is v, right? And finally this journey, again the distance is s, but the speed is w now. Okay, So if you can see over here, this s gets cancelled, right? That's why we can choose any number for our distance. The distance basically gets cancelled over here, okay? So that's why I chose 5 over here. You can choose any digit of your choice, okay? So now let's solve it. You'll get UVW in the when you take the LCM. So that will go on top as UVW upon. Now when you do it for this one, you'll get V and, so you can actually do it. Now I can see the answer, it's option C, right? So when you do it for U, you'll get this. When you do it for this one, you'll get the other two, U and W. When you do it for this one, you'll get U and V. Okay, you can actually try doing it. This is the thing that you'll get. Okay, so option C is the correct choice over here. Okay, so I hope the questions on average speed are very clear to you and are looking simple. Okay, now let's come to question 3. This is based on instantaneous term. Here they have given you the equation for time. You are asked for the time for the acceleration of this body. Okay, now how will you do this? You can just use acceleration as dv by dt. Okay, first of all, again you have to use v is equal to dx by dt. So differentiate this equation just 2 times, because here you have x. So once you differentiate it first time, you'll get velocity. Again, when you differentiate it, you'll get acceleration, right? So that is our idea over here. Okay, so that's basically how instantaneous terms are solved. Okay, those are the formulas that you learn: integration and differentiation. Okay, so here you are supposed to find the differentiation 2 times. Okay, first it will give us velocity, in the second time it will give us the acceleration. And mind you, you are supposed to find the acceleration at origin. Origin basically means the value of x is 0, the distance is 0. Okay, so differentiate it. So with respect to t, when you differentiate, you get 1. Here when you differentiate, p and q are constants, by the way. Okay, so here when you differentiate, you will get 2px dx by dt, right? 2px and then differentiation of x, which is dx by dt, or velocity, right? So you get velocity over here plus q into dx by dt, right? Q is a constant that comes out, and dx by dt, so that is again velocity, right? So you have some other equation now. Now we are asked for the acceleration at origin, right? So what we can do, we can find the velocity at x equal to 0. Let's see if that's helpful somewhere ahead. Okay, so we'll find what is the velocity at x is equal to 0. So when you substitute x equal to 0 in this equation, you'll find that the velocity over here is 1 by q. Okay, we'll just note it down in case we need to use it somewhere. Okay, it's 1 by q. Okay, now let's differentiate this once more. We'll get 0. Now differentiation of 1 is 0. 2p is a constant that comes out. X into v, we have to apply u into v. So u, which is x, into the differentiation of velocity, that gives us acceleration, plus v into differentiation of x, that again gives us velocity, right? Dx by dt is again velocity, so v square this time, and q into, now q is a constant that comes out, dv by dt, again acceleration, right? Now substitute x equal to 0, because we want to find acceleration at x equal to 0, right? And we can substitute v as 1 by q. Okay, the velocity at origin is 1 by q. Okay, we can substitute that, and finally we'll have our answer as 0 equals 2p. And when we substitute x equal to 0, this term flies off, plus v square, which is 1 by q square, plus q into a, right? Q into a. Okay, so we are supposed to find this acceleration. We can take this term to the other side, that will give us qa, so equal to minus 2p by q square, right? When you get this q down over here, you'll get that acceleration is minus 2p by q cube. Okay, yeah, that is the correct answer over here. Okay, I hope you were able to follow. We just differentiated it twice, substituted the value of x as 0, find the velocity at the origin, found the acceleration at the origin, and that was what we were supposed to find over here. Okay, so I hope this is very simple. Let's move to the next topic now. So let's come to our second topic, which is nothing but uniformly accelerated motion. So this is basically a motion wherein the acceleration remains constant, right? It has a fixed value, uniformly accelerated motion, yeah? And how do you solve such type of questions? It's very simple. You just use the three equations of motion. What are they? V is equal to u plus at, v square is equal to u square plus 2as, and finally s is equal to ut plus half at square. Also there is one more, we'll discuss that over here. Anyways, let's try solving this questions. Okay, and if you see, these are very straightforward questions, and such type of questions were asked in BITSAT. Okay, you just have to use the equations and you'll have your answer. You can see that. Okay, so question 1, we have a train over here which is initially moving with a velocity of 20 meters per second. Now some amount of retardation is applied. Okay, brakes are applied, so there is some negative acceleration, and after covering a distance of 200 meters it comes to rest. Okay, due to that applying of brakes. Okay, due to that retardation. Okay, you are asked for the retardation. What is the retardation that is applied to that train? Basically the negative acceleration. Okay, so you can see over here that we are given the initial velocity, right? We are told that the train finally comes to rest. Basically means that the final velocity is also given, it is 0, right? It comes to rest. Okay, and here the distance or the displacement is also given, right? So yeah, we are supposed to use, now we are supposed to find acceleration. Retardation basically means negative acceleration, so we have v u s. We want to find a, which equation? The third one, right? V square is equal to u square plus 2as. Yeah, this is the third one, I guess. Okay, so v square, here substitute v equal to 0, right? Final velocity 0, initial velocity 20 square 400 plus 2 into a into s. S is, if you see, it's 200 meters, right? So this is also 400, this is also 400. The answer that you will get for acceleration is minus 1 meters per second square, right? But retardation is asked, which means negative acceleration, right? So it becomes 1 meters per second square. Okay, retardation means this much amount of acceleration is applied in negative direction, in the opposite direction of the velocity. Okay, so yeah, our 1 meters per second square is the answer. Okay, here we get acceleration. You have to just change the sign, that will give us the retardation. Okay, don't get confused with the signs now. Okay, now let's come to question number 2. Here you are asked for the distance covered in the third second. Okay, now this is a different type of thing. This does not ask you for the distance in the whole journey. It does not ask you, suppose your object, sorry, it began at t is equal to 0 and went to move on for 3 seconds. It does not ask you for the distance in that entire interval. It does not basically ask you for the distance from t equal to 0 to t equal to 3. It asks you for the distance in a particular second, the third second, right? So here there is a simple formula which we call the fourth equation of motion. So that is given as, so the distance in a particular second, suppose the nth second, is given as u plus a by 2 into 2n minus 1. Okay, so distance in the nth second is basically given by this formula. Okay, if you didn't know this, please note it down. Okay, so let's find out the distance in the third second. Basically everything is given. If you see, u is 0 and acceleration is also given, so 4 by 3 acceleration divided by 2 into 2, 2 3s are 6, so in place of n just substitute 3, right? 2 3s are 6 minus 1, that is 5. Okay, fine. What do we get? This and this will get cancelled. 5 2s are 10, 10 by 3, 10 by 3. Okay, 10 by 3, option C is the correct choice over here. So this much meters is traveled in the third second by this body having acceleration so and so. Okay, so again, that was very simple, just a formula based question, right? Let's come to the third one. Now I think this includes using two equations. This type of questions is not asked, but still we'll do it just to get hang of it. Okay, so yeah, so question 3 over here, you have bus maybe which is starting at initial velocity 0, finally it attains a velocity of 144 kilometers per hour. And what are you asked for? You are asked for the distance covered by this bus. Okay, distance covered by this bus in this given interval of time when it moves from 0 initial velocity to 144 kilometers per hour. Okay, if you see, the distance is given in meters, so let's first convert this to meters and meters per second, right? This is velocity in kilometers per hour. Let's convert that to meters per second. And how do you do that? You should know it. I know most of you who are coming to this videos are from 12th standard and have forgotten your uh, 11th standard things. So in order to convert kilometers to meters, you just multiply it by 5 by 80. Okay, so 144 into 5 by 80. Okay, so this is in kilometers per hour. When you multiply it by 5 by 18, that gives you the velocity in meters per second. Okay, so what will be that? If you see, how can I cancel it? I can say 6 3s are 18, and what's that? 6 2s are 12, 6 4s are 24. Okay, again I can cancel it 8s are, so that is 40. Okay, I hope that's correct. So the final velocity is 40 meters per second. Okay, 40 meters per second. Again, I'll check it. 6 3s are 18, 6 2s are 12, carry 2, 6 4s are 24. Okay, 3 8s are 24. Okay, fine. Okay, 8 5s are 40. Okay, so final velocity is 40 meters per second, and this is the initial velocity. Okay, let's find out one more term. Okay, we'll find our s using ut plus half at square, but u is 0 over here, so we'll just use half at square. But for that we require the acceleration, right? How will you find the acceleration? You can simply use v is equal to u plus at, right? And you can solve that, and that will give you the acceleration. If you see u is 0, v is 40, the final velocity is 40, and the time taken for this not given. So sorry, the time was given as 20 seconds over here. Okay, so the bus moves from 0 initial velocity to 144 kilometers per hour in 20 seconds. Okay, so the time was given. So basically 40 by 20, right? This tu divide, that will give you the acceleration. So basically the acceleration is 2 meters per second square. Okay, so you can substitute that in half at square, and that will give you the displacement of this bus, right? So s is equal to half a is 2, right? A is 2, and t square, basically time square, that is 40. Sorry, that is 400, right? 20 square 400, this and this will get cancelled. Option C, 400, is the correct choice over here. Okay, so let's move to the next topic now. I hope these questions are very clear to you. So our topic number 3 is motion under gravity, and here you have to be careful because straightforward questions are not asked for BITSAT from this topic. Okay, here you will have conceptual questions being asked and also particular type of questions being asked. Okay, here you can see in question 2 we are just going to discuss it in a while. So I'll recommend you for this topic that you should go through a lot of previous year questions. You can go through the previous year questions of JEE Mains and see particular type of questions. Okay, questions which can be solved in only one manner. Okay, wherein you go to solve it by your own method and you get stuck somewhere. Okay, so those type of questions are very popular in BITSAT as well. You'll see questions coming in JEE and then they come to BITSAT. Okay, so focus on those type of questions, okay, which were asked in JEE and not yet asked in BITSAT. Okay, so that is what I can tell you, and those should be particular type of questions wherein they have a particular solution. Okay, now let's discuss it. Okay, let's discuss the topic. So here this is a very straightforward question. I've just taken it to illustrate motion under gravity. Okay, this type of questions are not asked in BITSAT. This is just for maybe fun. Okay, and this is the important question that we are going to discuss. Okay, anyways, here we have a building of height 20 meters. You are going to drop a ball from the top of that building with initial velocity 0. Basically drop it, right? So leave it, and you are supposed to tell the velocity when this ball reaches the ground. Okay, so here there are two ways of actually solving the problems of motion under gravity. Actually, you can remember the formulas, the facts, that the velocity of an object that is dropped from a height h, it is under root 2gh. You can remember that when an object is thrown up, it has a time of flight 2u by g and things like that. Okay, or else you can also solve it by using equations of motion, right? Because you also know that motion under gravity is just an example of uniformly accelerated motion, right? Wherein a is equal to minus g, acceleration due to gravity, right? So either way, your choice, you can choose anything. Okay, so here first of all I said that it will be under root 2 gh, right? So you can find it directly. Also you can use v square is equal to u square plus 2as. You can see that here u is 0, right? U is 0, so v square is this under root 2as, so that will give us v as under root 2as, and a is nothing but g, acceleration due to gravity. Also, if you are taking the downward direction to be negative, you can see that displacement is also negative and acceleration is also negative, so that makes it positive. Okay, anyways, we'll consider the downward direction to be positive for our convenience. Okay, so here the velocity will be given as 2 into g, we can take it as 10. Okay, and the height, where is the height? It's 20, so 200 into 2, that is 400, or 20 into 20, so under root of that, so you have 120 out. Okay, so 20 meters per second. Okay, so option B, 20 meters per second, is the correct choice over here. Okay, anyways, this was just for fun. This type of questions are asked in BITSAT. Okay, and I think this is in fact a previous year question. Okay, it was asked 2 times in BITSAT. Okay, let's go to it. Okay, so here you have a building of height h. Let me explain you what's happening in the question. So first, let's come to this building. Okay, you are going to go to the top of this building and drop a ball with initial velocity 0. Drop basically means you are going to leave it. Okay, so leave it. So the initial velocity of that ball is 0. Okay, so it is given that the time taken for this ball to reach ground is t. Okay, so you go to the building, top of the building, you just drop a ball. You have noted down that the time taken for this ball to come down is t. Okay, now coming to our second building, here you are going to do 2 things. One, you are going to throw up a ball with certain initial velocity u, not equal to 0 this time. So you throw it up, okay, and you note the time for this ball to reach the ground. Okay, this time is noted down as t2. Again, you are going to take the ball, you are going to, now again from the same building, you are going to throw it down. Okay, in this case you threw it up, now you are going to throw it down with initial velocity u. Okay, and the time taken for this ball to reach ground is t1. Okay, so basically to summarize it, the time taken for this ball to reach to ground, okay, it's t1. The time taken for this ball which is thrown up to reach the ground from this motion, this journey, takes time t2. Okay, and finally when you drop the ball, it takes time t. Okay, you are supposed to find what is the relation between t1, t2 and t. Now this is a particular type of question. If you go to solve it by your method, you may get the answer or you may not. Okay, so here is the approach, shorthand approach that you should follow to get the answer. Okay, so what will we do is we'll write the equations of motion. First of all, you can write this t simply as under root 2h by g, right? So the time of flight for our ball is simply given as under root 2h by g. If you have remembered the formula, you can also derive it using s is equal to ut plus half at square. U is 0 in this case, so half a is our g, right? We'll take the downward direction to be positive, okay, and upward to be negative. You can choose anything. Okay, answers will be same. So yeah, so our acceleration due to gravity g is in the downward direction positive and t square. So you can see that the time is 2s by g or 2h by g. The displacement over here is h, right? So 2h by g. Okay, so from there you can see that the time period is under root 2h by g. So rt is equal to under root 2h by g. Okay, now let's find t1 and t2. Okay, or instead we'll write the equation for we'll write s is equal to ut plus half at square for each of this. Okay, so we'll write h. So for the first one, you can see the displacement is always h, right? Even if it goes up and comes down, displacement is the shortest distance from the point, okay, from the initial point to the final point, right? So this is the minimum distance. Okay, so let's write it for this one first. Okay, h is equal to minus, now u is in the upward direction. Remember the conventions. So minus u, upward direction negative. Okay, u into t1, sorry, t2, it's t2 ut plus half a, now acceleration due to gravity g, downward direction positive, t2 square. Okay, Now let's write h is equal to ut plus half at square for this one. Okay, so h, again displacement is measured from here to here, so in the downward direction positive, and if you see the velocity is also in the downward direction, u positive into time is t1, fine, half g positive t1 square. Right, now what am I going to do? I'm just going to multiply t1 to this. Okay, multiply t1 to the first term. Okay, now this is the particular solution, right? This is the particular way of approach, okay, which will solve our question. So I'm multiplying t1 over here and t2 over here, and I'll add this equations. Okay, multiply t1, multiply t2 over here, and add this two equations. Basically what I'm doing is I'm eliminating this term. Okay, so here you'll get minus u t2 t1, here you'll get u t1 t2. Okay, so these two terms will get cancelled. That is what I'm trying to do over here. So ht1 plus ht2, or you can write h, I'll write it over here, ht1 plus t2, right? So ht1 ht2 on the left hand side, right? So h, take it common, so t1 plus t2, and here you'll get, so this will get cancelled, as you know. Here you'll get half g t2 square t1. Okay, so you can take half g common from everywhere, so g by 2, and here you have t2 square t1 plus t1 square t2. Is that it? Yeah. So you can also take some other things common from here. This is t1 plus t2, g by 2, and here you can take t1 common, right? You can take t1 and t2 also common. t1 is common, t2 is common, and you'll be left with t1 plus t2. Okay, you can multiply this inside and see that you'll get back over here. Okay, so you can take t1 and t2 common from these two terms, and you'll see that this and this also gets cancelled, and you get that 2h by g equal to t1 into t2. Now this is a very, very important thing. 2h by g is equal to t1 by t2, and if you see here, t square is equal to 2h by g, right? So you can equate this to t square. So t square is equal to t1 into t2, and when you take square root on both the sides, t will be given as under root t1 t2. So option B, t is the, basically t is the geometric mean of t1 and t2. Okay, you can understand it that way. If you see option D is dimensionally incorrect, so you can neglect that. It's either option A, C, or B. Okay, and we found the answer, it's option B. Okay, if you find this approach very, very annoying, you can skip it. Okay, but I recommend you not to, and you can also learn the way I told you, and yeah, you have to do such type of problems in order to actually solve them. Okay, and what can I say more? Let's proceed to the next topic. Okay, hopefully that will be more simple. So coming to our fourth topic, which is non-uniformly accelerated motion. Okay, a motion in which the value of this acceleration does not remain constant, it varies. Okay, so now this type of questions can be easily merged with the instantaneous term questions, because you use the same logic over there. Okay, differentiation and integration. Basically you can write velocity as dx by dt, or you can write it in integration form and find the distance, right? So that is what we are going to do it over here, and you'll see it how. Okay, it's just the same logic used in a different topic. Okay, so that is what I'll say. Let's go through the questions now. Okay, so first you are given over here the equation of an object which is moving. Okay, you are supposed to find the distance or the displacement covered by your object before it comes to rest. Okay, so how will you do this? First of all, we have to find the velocity, right? First of all, we'll find the velocity, equate it to 0. We'll find the time at which our object comes to rest. Okay, so what is the idea? We'll first differentiate this. We'll find the velocity, equate that to 0, get the time at which the velocity of that object is 0. Basically means that our object is at rest at that time, right? And that time we'll substitute in this equation, and that will give us the position of our object, right? Basically the distance at that particular instant. That is the distance that our object has covered when it is at rest. As simple as that. Okay, so first differentiate this. That gives us velocity. Dx by dt is velocity. 40 is a constant. 12t, that gives us 12 minus 3t square, right? T cube is 3t square, right? Now we'll equate this to 0. Velocity is 0, so you can easily see that 3t square will be equal to 12, or t square will be equal to 4. Okay, so which implies t will be equal to 2. Okay, we'll only take the positive value because time can be only in the forward direction, right? Or maybe not, right? Okay, anyways, we'll only take the positive value of time and we'll find s. Okay, now just substitute it over here and that should give us our s. Okay, so 40 plus 12 into 2, so 12 into 2 is 24 minus t cube. T cube is 2 cube is 8, so 24 minus 8, 16, 16 plus 40, 56 meters. Okay, so 56 meters. Option C is the correct choice over here. Okay, now let's come to our question 2, which has given us the initial velocity of an object as this, and the acceleration as a function of your velocity. Okay, this V stands for instantaneous velocity. A is the instantaneous acceleration. Okay, you can easily see that acceleration is varying over here. It's not constant. Okay, so the time taken for this to come to rest. Okay, so you are supposed to find when does the velocity of this object becomes 0. Okay, we can use this equation. In place of acceleration, we will use dv by dt, right? And we can write it this way, minus 2.5 into root v, right? So acceleration, we have just replaced it by dv by dt. Okay, now what can we do next? Bring the like terms together. So dv by root v, just like solving a differential equation. So into 2.5 into dt. Okay, variable separable, and then you integrate both sides. Okay, and you have to integrate within the limits of, so initial velocity is u, you know the value, and the final velocity you want it to be 0, right? The time taken for the object to come to rest. So you want to find the velocity, you want to find the time when the velocity is 0. Okay, suppose that time is t. Okay, initial time of course 0. So this is the velocity at u is the velocity at time t is equal to 0, and when our velocity becomes 0, the time is t. Our whole objective is to find this time t. Okay, so now substitute the values. Now integrate it, and what will you get? Okay, so you can substitute this as v raised to minus half. Okay, v raised to minus half. So instead of that, I know that 1 upon 2 root v is the differentiation of root v, right? So what I'll do a wise job over here. So yeah, so dv by 2 root v. Okay, I've just multiplied and divided it by 2, and 0 to t. Actually, I can take this 2.5 out anyways. Now 1 upon 2 root v, I know that its integration will be root v. So I'll get root v, and I have to just plug in the limits now. 0 u to 0. Okay, and here I'll get minus 2.5 into t, right? So solve this now. It's very simple. So 2 root v. So first you substitute 0. So that is basically 0 minus this value. So that is 6.25. Sorry, this I made a mistake over here. It's 6.25. Okay, or I can write it as 625 into 10 to the power minus 2. Okay, and here you'll have minus 2.5 into t. If you see this and this minus sign can get cancelled, and you'll have 2 into, again if you see 625 is the square of 25, right? So its root is 25. Okay, so 25 into 10 to the power minus 1. This minus 2 comes out as minus 1, so 2.5. Okay, I hope that is very simple. And 2.5 and 2.5 can get cancelled, and you'll easily see that t is equal to 2. So at t is equal to 2 seconds, our object basically comes to rest. Okay, let's briefly go through it. We just replaced a by dv by dt. Okay, variable separation. Okay, then integrated it, applied the limits from 0 to u, okay, sorry, u to 0, okay, initial velocity u, final velocity, it comes to rest 0, time initially 0, at when it comes to rest the time is t, okay. Then solved our differential equation, substituted the limits, and got our answer as 2 seconds, okay. Yeah, 2 seconds. Option A is the correct choice over here. Let's move to our next section. I hope this was very straightforward now. Coming to our next topic, which is graphs. Okay, graphs, mostly you are asked reasoning type of questions. You might be given a VT graph, as I told you in the beginning, and you might be asked for the acceleration, simple type of questions based on graph. Okay, you might be asked for the displacement, you'll be given the VT graph, then you just have to find the area under the graph, right? That is the thing that you are supposed to know. Okay, area, what does the area of a certain graph give you? What does the slope of certain graph gives you? Okay, so those are the questions that can come from the graph section. Okay, let's get to the questions now. So which of the following is not possible for uniform motion? Okay, so if you see the first one, the displacement remains constant with time. Okay, but that basically means that your object is at rest, right? It is not moving. The displacement remains same, right? It does not change. So basically your object is not moving, so of course it is not uniform motion, right? The object is itself at rest. Okay, so option A is not possible, right? But if you see, there is also an option both, so let's see A and B. Okay, so B, if you see, you'll see that the displacement is a very weird relation, right? You can see that at this time t, okay, you can be over here and you can be over here. Your object is over here and your object is also over here. Okay, your at a given time your object can have different displacement. Okay, at this given time, suppose this is 2 or 3 seconds over here, so this is suppose this is 2 seconds, so at 2 seconds your object can be over here, over here, over here, over here, and which is of course not possible, right? You cannot be over here and over here unless you are drunk. Okay, god damn it. Okay, anyways, so yeah, that is the point. You cannot be at infinite positions at a given time. Okay, you have to be at a certain position, right? So yeah, option B is also not possible, which means that option C both is the correct choice over here. Okay, both of this are not possible for uniform motion, right? This suggests the object is at rest, and this is something very weird, right? Yeah, so option C both is the correct choice over here. Okay, anyways, let's come to our question 2. Okay, here you are asked for the ratio of acceleration in the part OA and in the part OB. Okay, you are supposed to find the ratio of the acceleration in part OA to part AB. Okay, find this. If you see, this is a VT graph, and in VT graph, the slope of that graph gives you the acceleration, right? So for a VT graph, the slope gives the acceleration. Okay, so let's find out what is the acceleration in OA part. So that will be simply the slope, or tan theta, so tan of 30 degrees, right? So in the part OA, tan of 30 degrees, tan 30 is 1 by root 3, right? You can see in the second part, so this is for part OA, right? Now for part AB, you can see that now 60 degree is not the angle. Okay, if you see, the correct angle over here is 120 degrees. For slope, you have to see the angle that the line makes with the positive x-axis. Okay, so this is the positive x-axis and this is the line AB, right? So the angle is 120 degrees, not 60 degrees. Okay, anyways, even if you take 60 degrees, I think you'll get the same answer. Anyways, that is a matter of coincidence, because you are asked for the mod. So yeah, that is a matter of coincidence. Okay, it does not work otherwise. So you have to be careful. Take the angle between the positive x-axis and the line. Okay, so basically here the angle is 120 degrees. I can write it as 90 plus 30 degrees, right? So tan 90 plus theta. So tan 90, that will become cot, okay, cot 90. So tan 90 plus theta minus cot theta, right? So cot in the 10 in the second quadrant, that will be negative, right? So minus cot 30. Cot 30 is I think root 3. Okay, so minus root 3. Anyways, you are just concerned about the magnitude, right? So you have to take the ratio of this acceleration. So this is the acceleration in part OA. This is the acceleration in part AB, right? You have to just take the ratio of this two. So 1 upon root 3 divided by root 3, that basically means this will be multiplied, and you have a mod sign there. So just neglect this negative sign. So you'll get the acceleration as 1 by 3, right? If you take the ratio of this and this, right? So 1 by 3, option C is the correct choice over here. Let's move to our final thing. The final thing that we are going to discuss is the logic based question. Okay, we are going to discuss one previous year question from BITSAT which was logic based, okay, which could not be done by using any of the equations, formulas that you learned in your kinematics chapter. Okay, so let's move to that section now, which is miscellaneous or maybe other section. Okay, that basically does not fit into this chapter. It's mere logic. Okay, anyways, I hope this is very simple. Let's move to the next topic. So this is our last topic, and let this be your homework question, since we have, I think, almost exceeded the time limit. Okay, there is no time limit in fact, but yeah, we have recorded for a lot of time now. Yeah, so let this be your homework question. Do tell me the answers in the comment section. The correct answer will obviously receive a heart from me. Okay, it's a logical one. You cannot solve it just by merely using the equations or the formula. You have to use a little bit of logic. Okay, so that's all for today's video. I hope you enjoyed it. I'll see you soon in the next class. Also, consider subscribing. We are very close to 200 subscribers, so let's try to hit 200 subscribers through this video, and I'll see you soon in the next video. Till then, keep enjoying physics.